Hey, what's up everyone? My name is Akash and today I'll be walking you through the bank loan case study project which is given by the Trainity. In this project, I analyzed the loan application data to identify the patterns that could help the company predict the loan default. So the main goal was to use the EDA or exploratory data analysis to discover the key factors that will, of course, influencing the loan repayment risk and help the company make the informed decisions on the loan approvals. So I'll be presenting the step by step followed and the insights gains and how this analysis can contribute for the better risk management strategies for the business. So in this, I will be explaining you both the Excel sheet and the PPT or the PDF format so that it will be better understandable for you that how I executed this process using the Excel and how I represented what is the idea of making this project. So let's get started, jump into that. So this is the bank loan case study of first created by me, Akash, and this is the date of 6th September. So just getting started into that, I would like to give you the descriptions. A brief discussion about this. The bank loan case study involves analyzing the loan applications to identify the factors that will contribute to the loan default. So the objective is to help the company make the better lending decisions by understanding the customer and the loan attributes that will predict the repayment challenge. Using the Excel, the project includes the data cleaning, doing analysis, and visualizing to uncover the key patterns and insights that can mitigate the financial risk and improve the loan approval strategies. So there are three objectives. First, we will be identifying the patterns that will indicate the potential loan defaults. The second will be help the company make the data-driven decision making to minimize the financial risk. And the third will be understanding the customer and the loan attribute influencing the loan repayment behavior. So I will wanted to give you the approach that I taken to do this project. First will be the data cleaning. So we have addressed the missing values using the Excel function like the count and if and identified the outliers using the quartile and inner quartile methods like upper quartile method, lower quartile method, highlighted those. Then we have did the EDA exploratory data analysis, conducted univariate, bivariate, correlation analysis to explore the relationship between the customer attributes and the loan default risk, which will help find this like loan defaulters or the payment behavior of the customer. The third will be using the visualization like the bar chart, box plots, pie chart to visualize the key trends, outliers, and correlation within the data. Again, this part is very important because the visualization helps us the make the storytelling even more better and impactable. It makes the impact to the viewers, and also it will tell that what are the outliers, what are the correlations within the different like different numerical data set. Then we'll be just moving into the insights extraction. So we'll be analyzing the finding to identify the key predictors of loan default, such as the income level, the loan amount, the customer demographics, that will leading to the actionable business recommendations. So we'll be doing a multiple factors to gain these insights. So I will explain you later about all of this. And the last will be the data imbalance that will analyzing the target variable distribution using the countif and the pivot table. Again, this part is also useful because it will give us an idea that what is if there is an imbalance in our data, like what are the ratios of the defaulters versus non-defaulters, females versus males, or the income criteria. There are a lot more. Again, this is the Excel workbook hyperlink within this report. So if you just click into this, it will take you to my Excel sheet, which is this. I will have to show you. Just give me a second. Yes. So it will take you to my Excel sheet, like this application data, which was given by the Trinity, and what are the steps we have taken. So again, I will be explaining these steps, but tuned with me so that you will have a better decision. Okay, let's get started. So the tech stack used. We have of course used the Microsoft Excel latest version 2022 used for the data analysis, calculations, and the visualization purposes. In this project, the Microsoft Excel was used for the comprehensive data analysis, including the data cleaning, explorating, and the visualization low application data. Its advanced features such as the Power Query, pivot table, statistical functions that were the crucial for handling the missing data, detecting the outliers, analyzing the data imbalance, uncovering the correlation between the variables to identify the key factors that influence the loan default risk, and the analyzing bank loan case. So this is very powerful Excel, the latest version. Before this project, I was not having this, but I realized that I need to upgrade to this Excel 2023. This is very useful in making the EDA or any type of better graph decision making, like the outliers, the funnel chart, everything. So in the first project, like the first task was given the data analysis and finding the missing data handling. So we found initial data assessment. Let me take you to the Excel sheet. Just give us a moment. Yeah, this is it. So this was the initial data set given by Trainity, and it concludes, I think, 125 columns and the 50,000 rows, of course, which is a very used data to find the insight from this. So we have first calculated the count of the values, count of the rows, and then we make the percentage calculations. So for making the percentage of null value, we have used 1 minus B2 and then fix the uh, column, that is B2. So this will give us this Excel formula will give us the percentage of the null value. We can see that here we do not have any null value, but here starting to the on car is we have the 65% null value, and just moving on to the next type, the occupation type is having the 31% null value. Then this history, and we have the lord mode. Like from there we can see that more of 50% columns are even null. Okay, so I don't think we need this, and this was also not useful in making the EDA. This will make the confusions, and the result will be also not good. So for our tasks, I would like to represent that we have converted our days employed to the years using the first what we use the ABS function to make the negative number into the positive and then divided by 365, and then we have used the round function so that round will convert into the latest positive integer. So this is the days employed in here. Same thing with this is the days registration, days in publish. We have also highlighted the cells using the blue color, and yeah, we are also okay. Perfect. So let me come back to my presentation. Okay, well, fine. So initial data assessment, as we said, that the data initially contained 125 columns. After analyzing the percentage of the blank value, it was found that the only 65 columns had less than the 30% of the missing data. So removing unnecessary columns, we identified that columns with the more than 30% missing value were dropped from the dataset, leaving only the 65 columns with the more complete dataset for analysis. After that, we have formatted the following columns. We were converted from the days to the year for consistency and year interpretation, like days employed, days registration, days in published, year and birth, year birth. Already explained these ones. Converted to years using the ABS function and divided by 365. Then we also bind to the columns to the facilitate analysis and enhance interpretability, like empty income. So for the, making a better analysis, what we did, we make the bins to the income credit, then is, so that we will be more having features like what are the persons which fall under this category, this income range, this credit, or this age bins. Again, this was very useful. So we have taken these steps. This is the graphical representations of the columns with more than 30% values. You can check it out, pause it. You can check these are the columns which are only one column. I can see that ext source one is of 30% or greater null value, and the rest are more than 50% or even 45% more than. Okay. And even if you go to the columns names, that is house type mode, wall material mode, non-living media, land area, we cannot make analysis again from this kind of data set. Okay. The columns which are having the null value less than 30% is this one, the graphical representations, the percentage of null value in the columns, like empty credit, value, year, quarter, month, week, days. We can further take the steps why this data is having the blank and the people are leaving the blank, why it is. So this can also be further taken a step. I will suggest you to, like in our banking financial system, I will suggest that please make ensure that the data is correct and to be filled so that we can make even more conclusions about this the data set, right? Again, we can fill this data by mean and median. I will also did this. I will show you to the which columns. This consistent. So the second step is data analysis. Okay, just give me a second. We have did this in the next step. So I will give you that. I will show you that. Okay. So the data analysis outlier detections. So we have used the box plots, the scatter chart, the numerical columns with the outlier highlighted. And as explained, we have used the inner quartile range, where like lower limit, upper limit to detect the outliers on the incomes, loan amount. And again, we have applied the conditional formatting to highlight the outliers. And also after this, we will be changing these columns with our average value, right? So this is the graphical representations of the outliers in the employed in here. We can see that a person here is employed for 1001 years, and this is the value that many people I found when I realized this. Give me a second. Okay, this is the actual set. Uh, Again, this was the steps taken, like pivot table to extract these things and make the column chart. And these were our the final clean data set which we had extracted after removing those columns. Again, I mentioned these steps, but this is the Excel sheet. If you wanted to go, what the columns is not useful for us, so these are this, like the birth unit, this restrictions, cash loan type, target, etc. Again, this target is very useful, and we have made a lot of analysis using the target. So outliers, how we actually uh, find the outliers. So first, we find the minimum income, the first quartile, second quartile, third quartile. Also the maximum income, which is 11 crore 70 lakh, which is a vast number. And this will make the analysis worse. Why this will make that? Because we can see this graph. If you come here, we can see that people are having the income of approx maximum of 4 lakh and 68,000, which are defaulters. And if you talk about the non-defaulters, we can see maximum is going around the 3 lakh and 60,000, right? Or just give me a second. Sorry, 36 lakhs. 36 lakhs is the maximum of the income of the people's income total, right? But this is like 11 crore and 70 lakh. This is unpredictable. And if you include this, trust me, our analysis will does not make any sense. So we have again what we did, we have changed it with the average columns, right? Wait a moment, right? So I was explaining this. My again my Excel is hanging a little bit because this task is just wait. Again the Excel is I think hanging. Yes, can you see? Because the data set is too big. I think almost 135 or 136 MB, which is making the Excel not cool this time. Excel is I prefer that Excel is better for the small data set. I usually okay. Okay, let's come back to here. So what we did here is we use the inner quartile range. So the inner quartile range is Q3 minus Q1, and using this we have make the upper limit and the lower limit, right? I don't know what's going on. Okay. So upper limit and the lower limit, and then we use the if function here in our outliers. If function is used to find the outlier. Like if the cell is greater than or less than our upper limit and lower limit, then this cell will be said as outlier. Otherwise, it is the normal. So we can again check what are the outliers in our columns. We have made some analysis with this data, like the average of empty income total we found is almost 1,70,000. Some of the empty income total is this much, and the count of empty income total like almost 50,000. The maximum income total I have already explained that 11 crore and 70 lakhs. Minimum AMT total is 25,650. Standard deviation of 53,000. Standard deviation. Okay, sir. The variance is found to be 2.81 and the median is 1,45,000, right? Okay, let's come back to our presentation. Let's come back to our the presentation. Yes, here we go. So the next graph is of the count of children. We can see in this graph that we have the count of children which are making the non-defaulter. The candidates whose children is 0, also 1, 2, 3, 4, 8, right? If you go to the non-defaulters, we can see the people are having the max number of child here, that is 12. Again, this is outlier, but not impossible. It can be possible a person having of 12 uh, children or 11 children, 10 children. So I don't think we need to be exchange this because this can be possible. Again, income total has been explained. Also, the employed year has been changed. The year of registration. The people who have registration with us, who have registered with us, fall under the age category of we can see that 5 to 50. Okay, just come back. Let me come back so that I can show you properly in our Excel sheet. Yes, here. So this is the outliering income total, outliering the children's, as explained. The same thing we have did, that we find the Q3 and the Q1, then the inner quartile range, that is Q3 minus Q1, and then the upper limit, which is nothing but the G5 column, which is the third quartile range. plus 1.5 into the inner quartile range and same the lower quartile range, that is the first quartile range, minus 1.5 into the inner quartile range. Again, we can see we have included a table to find the outliers. What are the outliers? If we just untake all and click on the outliers and then OK, then it will give me the outliers. Like these are the outliers. Okay, let's just get back. Again, this is the map of outliers in years employed, like the people who have been employed for 1001 years was our outlier, and we had already. In the next step, we are changing with the average of years employed. Okay, so this is the dashboard explaining. We can interact with this to find what are the count of children, what are the empty income total. It's still loading. Okay, no issue. Oh, the outlier in the credit. Good question. We can say that A's do not have any outliers. It is 69, and that is possible. Let's jump back to the PPT to the next slide. Here we go. Yes, here we go. So the following is the graph to represent this. To represent this, we have to use the box plot and scatter plots, like the outliers in the credit, which was almost 30 lakhs, and in the good price box, it was around already also 30 lakhs. This can be considered as the outlier because this is much higher than the normal data set. So after identifying our outliers, we have gained some insights. So during the analysis, several outliers were identified. The dataset that significant deviated from the typical value. Like the employee duration, a candidate was found to have an employee duration of the 1001 years, which is clearly an unrealistic value and an outlier. Again, the number of children entry shows that the candidates have the 9 and the 11 children, which have extreme values that could indicate data entry errors or anomalies. Income of 117 million were identified, which is exceptionally high and likely an outlier compared to the rest of the dataset. The credit amount of 2.9 million, यानी कि 29 lakhs, was found, which is an unusual data, triggered and considered an outlier. Okay, good. So I would like to say you after identifying the outliers, what steps we have taken is to some needs to be as it is, but there were some columns which needs to be done by the average, like the income, or there are some columns. Let me show you. Yes, just give me a second so that I can show you the formula. Yes, so the empty income total. We have found the average, which was the average of income total, that is 1,70,000. So we have replaced the income of 11 crore. The same thing with the AMD good price was found to be 29 lakhs, which was extreme different from the data set and an outlier. So we have changed with the average function using the calculating average of these columns, which was 54,000, and then we changed here. Good. And risk being the same, you can see. But this step, we also removed some unnecessary columns. Some unnecessary columns, I mean to say, we can see here that there were 65 columns there. But when we come here, we can see only 23 columns are here. Sorry, 29 columns are here. We had count the columns using the count a function. So now we have the only 29 columns, and these columns will be important in our next analysis, like EDA, Exploratory Data Analysis. So let's come back to the task number C, that is the data analysis in the data imbalance. So the data imbalance is again useful to again useful, and in this step we have calculated the ratio of defaulters to non-defaulters, identified a segment imbalance in the target variable like loan type, gender, education type, income type. I think something is preaching. So we have calculated the ratio of defaulters to the non-defaulters, identified the segment like target variable. Target variable is defaulters, non-defaulters, loan type. What are the types of loans given? The gender type, the education type, right? The income type. And to represent this, we have used the pie chart, column chart, whichever the best suitable for our data set. Like if it were the small, we have used the pie chart. If it is long, we have used the column chart. So it will show the distribution of defaulters versus non-defaulters. So the data analysis or the data imbalance, the following is a suitable graph to represent the data imbalance, which is the count of target. We found that 8% is the defaulters of our applicants, while the remaining being like 45,973 is the non-defaulters. So this is again a very imbalanced data set, and if it is this is also good for the company, because if the in the imbalance is of the defaulters is very low, less, that is 8%, so we can tend or we can expect that there should be more candidates or lesser percentage of this data of the defaulters. The loan type, we have we can see that for cash loans, the people are much more interested in taking the cash loans, which were of 45,276, and the revolving loans of 4,723. The gender imbalance, again, female is found to be 32,823, while the males being the 17,000. So it is almost double in the number of females if you calculate the ratio. While the income type, the working professions and the commercial associates, this type of candidates are interested in taking the loans, while the lower being the businessman, unemployed, student, etc. And in the middle, we have the state servant or the pensioner. Pensioner. Okay. So this is the data analysis or the data imbalance. In the education type imbalance, we can see that this is the education type imbalance graph. This distribution shows that the majority of the applicants have a senior secondary special education level followed by the higher education. The very low number of applicants with an academic degree or the lower secondary education highlight the notable imbalance in the education level of loan applicants. This imbalance are important to consider in the analysis as they can influence the outcomes and interpretation related to the education background and the default risk. So, how actually we get these graphs or these graphs, like the data imbalance graph? I'm much interested in showing you this data set. Just give me a second so that I can load my Excel sheet, which is taking a longer than usual, but I will do this because this is my task. Just give me a second. बनत हो बनत हो खाई भाव बताइए नहीं मन से I'm so sorry guys, extremely sorry due to this, but here we have the Excel set. I don't know why it is taking longer time. Okay, I will show you in this slides in a while. Till then, I think better to move on to the next slide. Okay. So analyzing the data imbalance, what were the insights gained from this analysis? So the defaulters were found to be the 8% of the dataset, while the non-defaulters were the 92% of the dataset. This indicates a strong imbalance with non-defaulters vastly outnumbering the defaulters. The loan type. Moving on to the next, which were the loan type, the cash loans were the 45,273, while the revolving loan were 4,723. The data shows a significant skew toward the cash loans, which dominate the data set. Again, the gender, like the female candidates were the 32,823, while the male was 20,124. In a two instance, there is a notable imbalance in the gender distribution, with female nearly double the number of the males and a very small number of unknown other categories. So these imbalances need to be considered in the analysis as they can impact the performance of our predictive models and the interpretation of the result. Strategies such as resampling, stratified analysis, or the weighted may be needed to address these imbalances in the further analysis. Okay, the Excel is now showing very good, working very good. So we have used a pivot table here. The Excel advanced features, that is the pivot table. In that we have dropped in the rows the target and also in the values the target. And then we use the pie chart to represent this. That. Okay. The next were the loan type. The same thing we did with the loan type being dropped in the rows and the values in the values are the same. Note here the one client is payment difficulties and the zero with the all other cases are the non-defaulters. So if we are interacting with this like the cash loans or loan type, or from here if you wanted to see one type, so one is nothing here but the defaulters, right? The gender imbalance, the same, and the income type imbalance. This graph is showing the income imbalance, while the working professions being the 26,010, which is dominate the data set, and the applicants are also high in the working. The second were the commercial associate with 11,543. So these are the graphical representations. Again, this is far more better to visualize all the data data set in the one place or the one picture rather than single 50,000 columns. Now, how can we improve this? So we can found if a working candidate is applying, the there are much candidates or the higher number of this. While the state government is very less, the unemployed can even this should not be provided any kind of loan, even 86 it should not be given because this is a kind of unemployed and student that will ultimately lose our company or lose the business. In the businessman, we can suggest that this is very low. Even the businessman could return our installments, or this can be done. How? This can be done by collecting the proper kind of formatting like ITR or their GST filing. If you consider this, then we should be giving them. Otherwise, we can see that we are only impacting two businessmen, which is very low, right? Again, the education type imbalance. So the senior secondary people are much more interested and they needed the loan. But higher education, the applicants are only 12,164. So we can advertisement more on this kinds like higher education or the senior secondary social to gain more because already the applicants are interested in this. And if we bombard with an advertisement to this kind of candidates, I'm damn sure that this number will be going to be in the high, a little bit higher and highest. These were the loan types. Again, this is the graph uh, showing all the graphs in one place that we called again dashboard. Uh, Good. Come back to the presentation. Data analysis, univariate and the bivariate analysis. So the univariate analysis explored the task D were the data analysis to find the univariate, bivariate analysis or the segmented univariate analysis. We have did all of this, right? So first univariate analysis we had did, and then we had did the bivariate analysis. In the univariate analysis, we had explored the individual variables like the income, the loan amount, the age, etc. There are a lot more. In the bivariate analysis, analyze the relationship between the customer attributes, the loan default status, income range versus average credit limit, etc. Again, both makes importance and both are on their on level. Get into started with the univariate analysis. The following graph represents the univariate analysis for the following applicants. The applications received by the credit range and the applications by income range. So the graph A is we can see that we have made the bins for this as we have already introduced about this, and for the income category also we have made the bins. So in the credit range it is starting from 0 to 1.5 lakhs and then it goes to 1.5 lakhs. The maximum applicants received for the credit range is 9.5 lakh and plus. We can also see the second highest being the 2.5 lakhs plus to 3 lakhs. And as the credit range increases, we can see from 0.5 point 0 to 1.5 lakhs to 2.5 lakhs, there is a significant increase in this numbers of the applicants. While this is very much higher, and then again ups and downs were happening, and again this is in the middle range. I think 5 lakhs to 5.5 lakhs with the applicants of 3,700. While talking about the applicant by the income category, so we can see the maximum peoples with the income range 1 lakh to 2.25 lakhs. There is max number of applicants there, like 7,000 being the lowest, like the 7,000 48 applicants. Then we have the income range of 125,000 to 125,000, 150,000 incomes with the 78,000, 7,804 applicants. These are the data sets. I will talk much more in our insights. Okay, so these things have been explained already inside the highest number with this, the second highest range where there are 5 lakhs to 5.5 lakhs with 3,708. This has been explained, of course. And this image shows two bar charts that represent the distribution of applicants based on the two variables, the credit range and the income category. Here is the summaries. In the second chart, like applicants by income category, we can see the highest number of applicants fall within the income range of 100,000 thousands to 125,000 with 7,804 applicants. With the high, so let me. The distribution also shows a trend where the number of applicants increases with higher income range up to a point, but then drops off significantly. The very high income categories were 5 lakh plus and 4 lakh 75,000 to 5 lakh. The third and fourth univariate analysis is the applicants by education type and the applicants by family type. So the applicants by education type, we have the senior, yeah, secondary, yeah, for secondary special of 35,572 applicants is the highest and the lowest being the academic degree. While the applicants by the family type, the married is 32,094 94 and the unknown, with the unknown being the lowest to the 1. So what are the insights from this column and bar chart graphs? First, the applications by the education type, the highest number already explained is fall from the categories in the secondary with 35,572 applicants, and the second highest being the higher education with 12,000. There are the significant applicants in the lower category, partially the 620 and 20 in the lower secondary and the degree particularly. The distribution suggests that a large proportion of applicants have either a very high or a very low candidate with the fewer applicants in the middle range like incomplete higher with the candidates of 1620. The applicant by the family type, the highest number of applicants fall within the married range with 32,094 applicants. Single not married also has a high number of applicants of the 306. The distribution shows the trend where the number of applicants increases, therefore decreases with higher applicants up to a point, but then drops off. The fifth and the sixth analysis is the housing type and the income type. We have used here the bar chart to represent this. Just come to the insights. Applications by the housing type. The highest number of applications is from the house category with the 44,368 applicants. The second highest applicants are with the parents with 2,300 applicants. There is a significant applicants in the lower categories like 427 and 191 in the office apartment and the co-op apartment. The distribution suggests that a large proportion of candidates are already have either a very high candidate with fewer applicants in the middle range like municipal or fair rental. Applicants by income type. The highest number of applicants fall within working and commercial associate range with 23,010 and 11,554 applicants. There are significant applicants in the lower categories, partially 2 and 1 in the maternity leave and the business loan. The distribution shows a trend where the higher number of applicants fall in working and commercial associate. Right. We can also see in this graph that the maximum type of applicants fall under the working and the commercial. I think this analysis already been done in the where in task number 3 like data imbalance. We had already covered these things there. We can also see it in the bar chart also. This is the next level of analysis, the univariate analysis. So in this is a segmented univariate analysis. For this, we have taken the count of targets, like the targets with 1 and 0. That means 1 identifying the person with defaulters and the non-defaulters. We have been using a 100% stack chart and the lower or the range being 84% to the 100% because all of the columns is belonging to this and this will be better visualized. This can make the better visualization. So the insights from this is the highest number of applicants is from the non-defaulters in the income range of 125,000 to 150,000. That means 1,25,000 to 1,50,000 with 71 and 26 candidates. We can see from the right side the second one. The lowest number of applicants from the non-defaulters fall in the income range of 4,50,000 to the 4,75,000 with 19 applicants. We can see it here. There are significant applicants in the defaulter categories, particularly 678 and 620 in the income range, 125 to 150 and then 100 to 125. The distribution suggests that there is a significant distribution in defaulters and non-defaulters candidates. So again we can see that we are getting the second highest applicants from the non-defaulters of 64 and 28. That's 6,428. But the defaulter is also coming from this only. That is 620. And if you talk about income range 125,000 to 150,000, the income like the non-defaulter is 7,126, but non-defaulter is also highest in this. But if we talk about the ratio being much lower. So I forget to, not forget, I will explain right now our Excel sheet. Let's jump back into the Excel sheet. So these are the Excel univariate analysis, which has been again used by the pivot table. And as explained, the clustered column chart is where the bar chart for the applicants received by the credit range, for applicants by income category, again the bar chart, and with a design of black shading. The pivot chart has been again used here for the income type. Again, these are still loading. So the notice. We can take it here. Applicants by education type, applicants by the family type, applicants by the income type. Again, this take a lot of hard work for building this kind of charts, but ultimately we are getting a lot of experience from this thing. I ultimately enjoyed whatever I did. Okay. So the next thing is our bivariate analysis. So to explain this, our bivariate analysis, we will be coming back to our presentation. Data analysis with the bivariate analysis. Why it is useful? First, the question is that why we need to do a like graphs or the calculations, the anything which we are did. Why? So the bivariate analysis is crucial in understanding the relationship between the two variables. It is uses include identifying the key relationship. It helps uncover how one variable, example the income, affects the another, example the loan default, which providing insights into the factors driving default risk. Second, spotting trend and correlation. By analyzing two variables together, example the credit amount versus the default status, it reveals trend on correlation that can inform more accurate decision making and risk assessment. So refining predictive models. Third will be the refining. The bivariate analysis improves model accuracy by highlighting important variable interactions, allowing for more targeted loan approval criteria or the interest rate adjusted based on the correlated risk factors. So we have analyzed the relationship between the customer attributes, the reason rating by target, age distribution by target, the gender by target, education by target, and the loan default status, etc. So these are the graphical representation for the bivariate analysis for the different categories like reason rating by target, the age distribution by target. We have again used the bar chart and the cluster or the column chart to represent this kind of data set easier. And as we can see for the age category, we have used the beam range which we have created from the starting. And here in the education by target, we have used a stacked column chart for the defaulters and non-defaulters. Then gender by target, right? Okay. So come back to the insights. What are the insights from these graphs? So the reason rating by target, that is the first graph. So the most non-defaulters are in the region with the rating of 2. That means 34,043 non-defaulters. While the number of defaulters in this same region is relatively small, that is 5,006. The region with rating 1 and 3 have the significant fewer defaulters and the non-defaulters. This suggests that the region with the rating of 2 are less likely to have defaulters, do they contain a majority of the population. Okay. The second graph is age distribution by target. That means this one. So the non-defaulters are most prevalent in the 30 to 35 years group. That is 18,000 2024, followed by the 40 to 60 age group, that is 15,620. The number of defaulters is relatively low across all age groups, with 30 से 45 age group having the highest number of defaulters, 17 से 91 compared to the other groups. So if we compare other groups, we have the ratios, we have the highest number fall under this category. The ratio of 30 से 45, the defaulter is highest. This indicates while the 30 से 35 group is the largest proportion of defaulter, it is still lower compared to the non-default. The third is gender by target. That means the third graph representation. So from this we have the insights that there are more non-defaulters among the female, that is 30,559 compared to the males of 15,412. The number of defaulters is also higher among females, that is 2,264 than males 1,764. But the ratio of non-defaulter to defaulter is more favorable for males. That means although we have the higher number of candidates coming from the gender type of females, but if we talk about defaulter to non-defaulter case, the females are greater defaulter than males. So this suggests while females make up the large proportion, they also have a higher count of defaulters, although they still mostly consist of non-defaulters. Education by target. Education with the senior secondary special education are largest group of non-defaulters, 32,000 for university. This one, the fourth graph. We can see the last graph, that is this one. The number of defaulters is relatively low across all age groups, with the range 30 से 45 is having the highest number of defaulters. 17 से 91 come, sorry, here. There is a significant number of defaulters, 32 in this education category as well, but non-defaulter still dominate. The number of defaulters is much lower in the higher education group, that is 606, and incomplete higher group 138, suggesting that higher education might be associated with lower likelihood of defaulting. So this is our fifth and sixth bivariate analysis graph. In this, we have take the average of empty credit and by the column income range. So this is showing the average credit by the income, and the sixth one is showing children versus target. And how many count of children the candidate is having, how many they are of defaulters versus non-defaulters. So these are some insights. The above image already provides insights into the two additional aspects of dataset, the relationship between the income, credit amount, and the distribution of defaulter versus non-defaulter based on the number of children. So first we'll be talking about the average AMT income, average AMT credit by income range. So this chart shows that the income range increases, the average AMT credit amount also tends to increase. For income range above 5 lakh, the average AMT credit is the highest with amount exceeding 1 crore and 10 lakh. The credit amount steadily increases with each higher income bracket, with the lowest average credit observed from the 50,000 to 75,000 income range of 3,45,000. The 75,000 to 1 lakh income range has a slightly higher average credit amount, that is 4 lakh of 4 lakh and 70,000, indicating a positive correlation between the income and the credit amount. So this is showing a best correlation factor that when the income range increases, the credit range is also increasing. The last chart, which is the children versus target, when you give this chart, So the graph displays the distribution of target based on the number of the children. Household with no children have the highest count of non-defaulters, that is by their 272 and a notable number of defaulters, that is 26 or 44. As the number of children increases, the number of non-defaulters generally decreases and the number of defaulters also decreases. Let me represent this here. Yeah. So we can see when we move uh, count of children here, the applicants significantly drop from 4 children, like 5 children. We have the 10 applicants in 6 to 1 and also the defaulters are less. So this was I was talking. For household with more than 5 children, both non-defaulters and defaulters are situations indicating that having more children may correlate with lower likelihood of default, but the population size in this category is still small. This is the unique case for household with 9 children where both non-defaulters and defaulters are represented by a single instance each. The sixth, the seventh and the eighth bivariate analysis is on the income type by target and the income range versus target. Again, we have used here is a 100% clustered column chart and a column chart. So these are the insights from this. The first chart was the income type by target. I think it should be visible. Yes. So income type by target. Working. The working categories has the highest count of non-defaulters. That is 23,000. And a significant number of defaulters is 24,061. This indicates that working individuals make up the large proportion of the population and have a notable through relatively low default rate. Okay. The state servant, this group has a sustainable number of non-defaulters, that is 3,314, and a small number of defaulters, that is 198, suggesting a low default rate among the state servants. Pensioners also show a low default rate with 8,490 non-defaulters while 501 defaulters. Commercial category shows a similar pattern with 10,679 non-defaulters and 164 defaulters. Businessman category has very few instances with 2 non-defaulters and 2 defaulters, which is too small a sample to draw significant conclusions. Students shows a minimum default rate with 5 non-defaulters and 4 defaulters, but the total number are also very low. Unemployed. Interestingly, the unemployed category has no non-default and 2 defaulters, indicating a high risk of default among the unemployed. The last one is income range versus target. Again, this graph. Here one indicate the defaulters and here indicate the non-defaulters and these are the income bins. Starting from 50,000 to 75,000, which goes up to 5 lakh. So the graph shows the higher income range generally have the lower default rate. Okay. The income with 1 lakh to 125,000, this range has the higher number of non-defaulters, that is 61 and 28. So you can check it out here. Here, here we have 64, 28, and a smaller but significant number of defaulters, that is 620. I think 64, 20. Okay, maybe this kind of a little mistake by me can be done. I will change this in the formatting. In the last stage, I will change this. And a smaller but significant number of defaulters, that is 620, with the income range of 50,000 to 75,000. There is a notable number of non-defaulters, that is 2,980, and a lower number of defaulters in this range. Okay. For the income range of 2 lakh to 2 lakh 25,000, another significant number of non-defaulters is 5,060 and the lower number of defaulters 491. As the income range increases, the total number of both defaulters and the non-defaulters increases, with the highest income breakouts brackets 450 to 500 income, 500,000 income, showing a very few stance of defaulters, suggesting a strong correlation between the higher income and the lower defaulters. So I will be explaining all this bivariate analysis in our Excel sheet. Let me load that. It may take 10 seconds. Just wait. So, so here you go. I think it taken almost 60 seconds. I don't know why it's taking too much, but okay, here we have. So talking about this, we have used the pivot table here. So on the row level, we have drawn the income range, and on the values column, we have drawn the average of AMT credit. Right? And then we have used a bar chart to represent this. Same thing we have did here in the reason rating by target, again with the count of target by the income range and the income range versus target. This was the graph representing that. These are the two graphs like the age distribution. So for that, in the column, we dropped the target, and in the row level, we dropped the age category, so that we can have a different kind of visualization to interact the viewers. So because anyone will get bored of doing the one kind of category, so use the different kind of categories. Again, these are the small, so we have used the column chart. Otherwise, we'll be using a bar chart. We have did the same thing here for the gender type. Again, we do not need to hover over because we had already added the data labels here. These are the income type by the target, the children versus target, and the name of education type or the education type versus target. So this was all said about our task number 4, and now we'll be moving to the last and the very important analysis, the top correlations for the different scenarios. So again, the correlation analysis has been done on the two bases. First, the non-defaulters, and second, the defaulters. Right. So how we executed this? Let me come back to my Excel sheet here. So again, this is what we have included. All the univariate analysis one at a place, and all the bivariate analysis at a one place. Okay. So the non-defaulters. For non-defaulters case, what we did, we come back to our clean data set that is here, and from target we have set it to 0. So when we filter it with 0, then we come here and paste the columns which were the type of numerical columns. So we can see we have total numeric columns of I, that is 9 kind of numeric columns which we'll be using for the correlation. Target correlation for the 0, target 0 correlation, or the non-defaulters we can say. Let me explain this. So this is the table map. For the row level, we have dropped the children, count of children, empty income total, empty credit, reason population related, days employed, days registration, and other two columns. So this first row is showing the correlation of count of children with itself, and the second, that is Shivan column, is showing the relation with count of children with the empty income total, right? And then count of children to the empty credit, and a count of children with the region rating population relative here, and so on. The again we'll be moving empty income to credit total, empty income total with the kind of children, count of children, and then with itself, and so on, drop down. So again, we have the negative correlations, we have the positive correlations. So some of them are very positive, some of them are very negative. So out of them, we have first draw, copy and paste all the tables here without any formats or without any formulas. Because here we have used the formula. If you go, we have used the correl function. Correl function with a non-defaulter column with a non-defaulter. That is here. Non-defaulters count of children to itself, and then non-defaulter to income, like that. Understand? So we have to remove this formulas. So we remove the here, and then we also remove one, because the relationship, because when we are talking about the correlation, it does not make any sense. The correlation of count of children with itself, it should be the related with another columns. So we have dropped the count of relation in the top 10 categories. Right. So when we drop, we use a Excel. We have selected these columns, and then we come to the conditional formatting and highlight cells. So top bottom rows, we have top 10 items. So here we got top 10 items. Again, we can find the duplicates like suppose the count of children is with the relation with the empty income total. But when we come to this column, so again this will show here the relationship between empty income total and the count of children. So we will have to remove this kind of duplicates because it will be double relationship with the two columns, which we don't want. So we remove them and then we copy and all these 10 positive top 10 and then we drop down here their rows columns, these two row columns. So we have found that the AMT income total is highly related with the AMT credit. That means higher the income total, the higher the credit is. Understand? We had already explained in this graph like the bivariate analysis or the univariate analysis, bivariate analysis. Okay, and the days employed in years. The second correlation is found to be days employed in year with the days employed in publish. So, which is of 0.27. Again, let me explain if it is closer to 1, that means highly correlated. If it is closer to -1, that means highly negatively correlated. That means higher the income total, lesser the credit is. But this is not the case here, it is positively correlated. So the days employed with the days in publish, and then the days employed in years with the days registration in year. We have the empty income total with the region population rating, days registration in year with the days in publish, empty credit. So from this analysis we can suggest that we should be published earlier so that the employed could be earlier also. If the employed in year is earlier, the registration is also earlier, and it is a positive correlation between them. Empty income total, if it is higher, then the region population relative is also higher. Days relation, days restriction in a year is higher, then days in public is also higher. Empty credit to the region population relative is also around 0.955. So when it comes down to 0.95, this does not make any sense. This is less positive correlation. So these are some of them, like count of children with the empty income total, count of that is higher the children, higher the income total is, that is less positively related, count of children with the daily basis. These are the top 10. For this graph, this table, correlation for the applicants with the payment made on time, we have used this kind of column chart, which is showing a negative values also and the positive value also for all the cases, ups and down. If you hover over, we can find what is the correlation factor is, right? But this is confusing. So we have used the table here and we have found extracted the top 10 using the conditional formatting and parentheses, right? I will be also showing this in the PPT. So we have identified the top correlation variable with the non-defaulters in different scenario, highlighted strong predictors like income level and loan amount. Column chart is showing the top correlations. Non-defaulters case, the following table represent the non-defaulters analysis already discussed. The following graph represent the non-defaulters analysis. These are the top 10 non-defaulters analysis. And now let's move on to the top correlation for the different scenario, and this is the correlation analysis for the defaulters. This is again useful in identifying the defaulters. So we have identified the top correlations variable with defaulters in different scenarios, highlighted the strong predictors like the income level and the loan amount, the graph, the column chart showing the top correlations. These are the tables showing the defaulters correlation with the all possible cases, and these are the graphs showing the defaulter correlation with the all possible cases. Again, this is interactive graph, I think, but we have used all kind of graphs so that we can interact the viewer. The defaulter case inside the following graph represent the top 10 defaulter correlation. So let's come back to the Excel set. How we executed this, how we use the formulas. I think we are pretty soon. So client with the payment, again it's still loading. I don't know whatever. Okay, so till the it load, I'll be coming back to the PPT. We can also explain in PPT. Not issue. Not issue here. So like the non-defaulters, we have used the defaulters from our clean data set to the target one, then set the target one, then copy and paste to the new sheet. This like 8 columns, 8 numerical columns to find the all possible correlations. Then we use the same correlate function for the count of children to the empty income total, count of children to the empty credit, and we have found this table. Then we select all these columns and we go to the our presentations, sorry, our graph, insert a graph and we inserted a column chart here. And this is a clustered column chart. Now moving on to, we have used the same conditions of identifying the top 10 correlations. The following graph represent the top 10 defaulted correlations, and the first being count of children to the days in publish. So if we talk about the defaulter case, we have the slightly highest number. We have a slightly higher number with count of children to days in publish. So sorry, days employed versus days in publish. So higher the days in employed, the higher days in publish. And then we have the count of children versus the days in publish. So it suggests that the defaulters is coming from the higher count of children. If the higher count of children is, the days in published being also higher. If the days in employed being the higher in the defaulter case, the days restriction being also higher. Days restriction is higher, then days in published also being higher. If the credit is higher, then it is highly correlated with the region population relative. That is, higher the credit is, higher the region population relative is. Higher the count of children is, region rating client with city is higher. So these are the correlation. Again, we can see that in the defaulter case, it is less positively related even in our top 10 correlation, right? Only one being more positive, that is days employed in daily registration in the defaulter case, and all being the less positively correlated. Okay, okay, fine. I'd like to show you Excel sheet right now. This was again the Excel correl function used here. We drop copy and paste the values only here, and then we have identifying Using the conditional formatting to put the top 10, we have dropped down here, their correlation, and this is our graph. For client with payment difficulties, so we have set the target to the 1 and we will use the same tactic. Good to go. Again, if we want to set it from highest to lowest, we can also do that. Highest to lowest, largest to smallest. So the largest being this yes, days employed in here with days in published and days employed in years with the days employed in registration. These are the graphs, we can hover over it. Count of children with the region rating. You can see this. The larger we can see the box is, the larger it is related positively or negatively. Like the days employed is negatively related here with the count of children. Okay. So these are all set, guys. So these are all set. Let's come back to our PPT. So we have also identified some factors here. The new strategies we have included is the top three strategies. The risk-based assessment, we have developed a model to classify the applicants into the risk categories like the low, medium, high, based on the key variable like income, credit history, education level to tailor loan approval criteria. Then we have the behavioral analysis. So we have analyzed the customer behavior such as spending habit, previous loan repayment to understand the factors that is influencing the successful loan, the repayment and the refine approval process. Predictive modeling. We have created a predictive model to identify early warning signs of the potential defaulters, enabling proactive measures to mitigate the risk before the default. Come back to the final results. These are our results from this data set. So we had identified some results where the higher income reduces default risk, but high loan amount increases it. Understand? Higher the income is, that means the lower default risk, but higher the loan amount, the default risk will increase. Gender and employment type also influence the default likelihood, as we seen in the females candidate. And while if you talk about the employment, so employment is getting the more non-defaulters, right? So consider the third point, consider stricter approval criteria for high loan amount. This is the suggestion that if the criteria is stricter, the lesser will be the defaulters. Offer tailored loan terms based on income and employment status. So if the income is high, this would be tailored to give the loan, and if the employment status is good, we should be focusing on these key factors to mitigate the default risk. The some other results after doing this project. So these are the results that we have improved understanding. After doing this project, I improved understanding of the factors that leads to the loan default, developed strategies to mitigate the risk and optimum loan approval process. Potential reduction in financial losses due to the better informed lending decision. And trust me guys, after doing this project, now I have a better overview and I am very much confident about the loan approval cases in banking sector that can help reduce the financial losses due to the better informed decisions. So thank you so much. Hopefully, this report can make our company even better. And again, I have included the hyperlink of the Excel file. So if you forget to click on that, make sure you type it here on this hyperlink. Click on it, it will take you to my Excel sheet. For further queries, you can contact me on my phone number or you can email me on the working email address that is kingakazdi@gmail.com. Thank you so much. I enjoyed very much the project given by the Trinity. Thank you so much.